Hello, this is question 9 on your AQA paper 2 from November 2021, and you have a robotic arm which is attached to a flat surface at the origin O. It's used to draw a graphic design. The arm is made of two rods, OP and PQ, each of length D, which are joined at P. A pen is attached to the arm at Q. So this is what is drawing when this is moving. The coordinates of the pen are controlled by adjusting the angle OPQ and the angle theta between OP and the x-axis. For this particular design, the pen is made to move, so the two angles are always equal to each other. So this one and this one are going to be always the same, and between 0 and 90 degrees by half radians. So that the x-coordinate of the pen can be modeled with this equation. So that x-coordinate that I mentioned is this one here. So this is x. There are a few ways of doing this question. I'm going to show you one, but that doesn't mean that it's the easiest or the only one. If you consider, let's say, this big triangle, so let's say this is A, and it's the x-coordinate of P. We can consider this big triangle and then say that OX, or X, because it's how we are calling the coordinate of this point, is going to be OA minus XA, or I'm going to call this point B. I think it's going to be better. So OB, which is X, is going to be OA minus OB. And those are going to be relatively easy to find. So let me write that down. So X is going to be OB, and OB is going to be OA minus BA, or AB. OA, so this one here, if you look at this right-angle triangle, rectangle here, is adjacent to the angle. So we can say that adjacent is the cos theta. So that one is the cos theta. And this distance here, we can look at these two triangles, or we can just think on a bigger triangle. So we can extend this bit here and this bit here, and this distance is the same as this one, and we can consider this big right angle triangle. I think it's just simpler. We are considering this right angle triangle because we know the length of one of the sides, the hypotenuse. In the other one, we don't know where this point is. Angles, we know this angle here, just looking at this triangle, this angle here is pi, because the whole triangle is pi, minus 2 theta, which means this angle here is going to be 2 theta, because 2 theta plus pi minus theta is pi, and it's a straight line, so it must be pi. So this is 2 theta, which means this angle is going to be 2 theta, because they are corresponding, This angle and this angle are corresponding. This is pi half, so this angle here at the top is going to be pi half minus 2 theta, So if this is pi half, this one plus this one must be the other pi half, I tell you that because we could say that this distance, so BA, that's the one that we need, is really the cos 2 theta, because it's adjacent again, but they have sine. So instead of doing cos of this angle, I'm going to do sine of this one, because sine of this one is the opposite. So it's just another way of doing it. Minus this bit. This bit is going to be the hypotenuse times sine of this angle, because it's the opposite. So minus the sine pi half minus 2 theta. We can take the outside, and then we have this cos theta, but here we have a minus and we have these two swap. But remember, when we have sine of an angle and the negative one. So if we have sine of an angle and the negative one, they have different signs. So if I have an angle here, alpha, and I have minus alpha, sine, which is the vertical line, is the same, but just sign change it. Yeah, so I can say that sine minus alpha is minus sine alpha, which means here I can write this as plus sine minus this, and minus this is just swapping the 2 theta with the pi halves. Yeah, so the minus becomes plus, and then this is minus this angle. So I can write that this is the cos theta plus the sine, the minus that, which is 2 theta minus pi halves. Yeah, and this is what we have to find. So I just can take the outside, plus sine 2 theta minus pi halves. Yeah. And that's it with this part of the question. You can use this big triangle that I use, or you can use this small triangle and this one. I think this one is faster, but it's really a bit up to you. Next part of the question says, hence, so we are going to use that, so that x is d and this bracket here. If it say hence, we are going to use this information. So what we are going to try is to write this in this way. Yeah, so let's going to see, we have cos theta already, cos theta, and we have an addition here and 2 theta. So let's going to see what we can do with this. Sine 2 theta minus pi half, sine 2 theta minus pi half. If we use the addition formula for sine, so sine A plus B, we have sine cos, so sine of the first one, cos of the second one, minus cos sine, so cos of the first one, sine of the second one. Cos pi half is 0, so that half is 0, and then sine pi half is 1, so this is equal to minus cos 2 theta. And then using the double angle formula, we know that this can be written in terms of cos squared, so I have minus, and this can be written as 2 cos squared. Remember, the addition formulae are in the formula booklet. The double angle are not, but they are easy, very easy to deduce. So we can write that this is just expanding the bracket, 1 minus 2 cos squared theta. So this is this bit here, and I have the cos theta. So I can say that x is the cos theta plus 1 minus 2 cos square theta, which is precisely what we have to prove. Yeah, so 1 plus cos theta minus 2 cos square. Then it can be shown that x can be written this way. They don't ask us how or to prove or anything. State the greatest possible value of x and the corresponding value of cos theta. So this is going to be maximum when this is 0, because this goes square, so the minimum value that can take is going to be 0, and this whole thing is going to be maximum when I subtract the minimum possible value that I can subtract. Yeah, so the maximum value is going to happen when this bracket is 0. So the maximum value is 9d divided by 8. And that bracket is 0 when cos theta minus 1/4 is 0, which means cos theta is going to be 1/4. They don't ask us the value of the angle, they just ask value of cos theta. Yeah, so we just leave cos theta is 1/4. And the last part of the question says, figure 3 below show the arm when the coordinates at its greatest possible value. Yeah, so this is the maximum x yeah? And find in terms of D, the exact distance, OQ. So they are asking us about this distance here, OQ. This coordinate, so what is maximum is the X. And we know the maximum value of X is 9D divided by 8. So that means that we know this here. This is 9D. We don't even need that. We have an isosceles triangle. So this isosceles triangle, so we have something like this. This is D, this is D, and this is theta. And we know what theta is when this is maximum. We don't know theta, but we know cos theta. We know cos theta is 1/4. We just found it, yeah? So here, cos theta is 1/4. So what we can use to find this distance OQ, that's what I need, is, I'm not going to write it X because we are going to get confused. We can use cosine rule. So I know that A squared is going to be one side squared, the other side squared, minus 2 times one side, the other side, cos of the angle in between, yeah? And I know everything here, so, well, in terms of D. So I have that A squared is 2D squared minus cos theta is 1/4 times by 2 is 1/2, so minus D squared half, D squared divided by 2, which is 3/2 of D squared, which means that A is the square root of that. So it's the square root of 3/2 D, because root of D squared is D, or I can rationalize, and then I have, if I multiply both numerator and denominator by √2 to get rid out of the root in the denominator, I will have √3 multiplied √2, so just multiplying by √2. I have that A is √6 divided by 2D. And that's the value. This is OQ, the distance OQ. Yeah, and that's all with this question.